Close your eyes for a moment, even as you listen. Imagine drifting away from the Earth, slowly, gently, without effort. Watch the blue curve of our world shrink behind you, smaller and smaller, until it becomes a single point of light among countless others, and then nothing at all. You are no longer bound by gravity, no longer bound by time, by deadlines, by the small worries that filled your day. You are simply moving, weightless, through the long silence between the stars, and ahead of you, scattered like grains of sand across a black, endless shore, lie worlds that human eyes were never meant to see. Not one of them, not a dozen, but thousands of planets orbiting suns so distant that their light left home before you were born. Traveling for years, for centuries, for millennia, just to reach the dark mirrors we call telescopes. Most of these worlds are nothing like Earth. Some are larger than Jupiter, wrapped in storms that could swallow our entire planet without leaving a ripple. Others are smaller than Mercury, scorched bare rock spinning so close to their stars that a single day lasts only a few hours. There are worlds with skies the color of blood, worlds with two suns rising at once, worlds where it rains substances that have no name in any human language. And somewhere among this glittering, impossible catalog of distant places, scientists quietly agree on something extraordinary. There is one planet, just one, that astronomers have come to call the most beautiful planet ever found. Not the largest, not the closest, not even, by some definitions, the most Earth-like, the most beautiful. A planet so visually striking, so strange in its loveliness, that the people who first saw its true colors say it changed the way they thought about the universe. But here is the first quiet mystery of tonight's journey. Beauty in space is rarely what it seems. The same blue that makes a planet look peaceful from a distance can hide an atmosphere that would tear a spacecraft apart. The same shimmering light that looks like sunrise on a calm ocean can be the glow of a storm violent enough to end a civilization in seconds. Out there, beauty and danger are almost always the same thing, simply viewed from a different distance. So tonight, we are not going to rush toward an answer. We are going to travel slowly, the way starlight itself travels, patiently, silently, across unimaginable distances, visiting some of the strangest, most breathtaking worlds ever detected beyond our own sun. A planet made of diamond, a planet being slowly devoured by its own star, a world where it rains liquid metal sideways, oceans without any visible end, a planet darker than fresh asphalt, swallowing 99% of all light that touches it. A world with two suns in its sky, just like the planet you may remember from a beloved film, except this one is real. And only at the very end of this journey, once you have seen the full strangeness of what lies out there in the dark, will we finally arrive at the one world that earned the title we began with tonight, the most beautiful planet ever found. You don't need to remember any of the names. You don't need to take notes. There is nothing to learn here, nothing to study, no test waiting for you at the end of this. Just let the universe unfold at its own pace, the way it always has. Long before there were eyes to watch it, and long after those eyes will have closed. Settle in. Let your shoulders soften. Let your breathing slow to match the silence of the place we are about to enter. Because somewhere out there, drifting around a star whose name you have probably never heard, a single world is waiting, quietly, patiently, for you to finally see it. Let's begin. Before we drift any further into the dark, let's pause here for a moment, in the calm space just before a long journey begins, and talk about what is actually waiting for you tonight. For most of human history, the night sky was simple. There were stars, fixed and eternal, scattered across the darkness like dust on black glass. People imagined gods among them, told stories about hunters and bears and lovers turned into constellations, and never once seriously wondered whether any of those distant points of light might have their own planets, their own oceans, their own storms, their own quiet, dark mornings. It was, for thousands of years, simply assumed that planets were special to us, a privilege of our solar system alone. Then, in the final years of the 20th century, almost without warning, that quiet assumption shattered. Astronomers began detecting tiny, almost imperceptible wobbles in distant stars, the faintest gravitational tug of something orbiting them, unseen, in the dark. A planet, pulling on its star the same way the moon pulls on Earth's oceans, only far too small and far too distant to ever be seen directly. The first confirmed discovery, in 1995, was almost unbelievable to the scientists involved. A planet half the mass of Jupiter, orbiting its star in just 4 days, so close that its surface temperature would be hot enough to melt lead. It shouldn't have existed, by the theories of the time. And yet, there it was. That single discovery opened a door that has never closed since. Within a few decades, the search for what scientists now call exoplanets, worlds orbiting stars other than our own sun, exploded into one of the largest scientific undertakings in human history. New telescopes were built specifically to hunt for the tiny dimming of starlight that happens when a planet passes in front of its star. Space observatories were launched into orbit with a single purpose: to stare, unblinking, at hundreds of thousands of stars at once, waiting patiently for the smallest flicker. And the flickers came, thousands of them. As of now, scientists have confirmed more than 5,000 exoplanets, with thousands more candidates waiting to be verified. And remember, this number represents only the tiniest, most accessible fraction of what is actually out there. Our own galaxy alone, the Milky Way, is now estimated to contain more planets than stars. Many stars host several. Some host entire miniature solar systems, smaller and more compact than our own. So why does this matter to you tonight, in this quiet, peaceful place? Because among those thousands of confirmed worlds, a small handful are not just scientifically important, they are visually staggering. Worlds whose true colors, once finally measured by instruments sensitive enough to capture them, turned out to be more vivid, more strange, more dreamlike than anything found in our own solar system. Tonight, you will travel to 10 of the most extraordinary of these worlds. Each one was chosen not simply because it is unusual, but because each one carries a quiet emotional weight, a moment of wonder, a twist scientists did not expect, a beauty that conceals something far stranger underneath. And by the time we reach the final world of this journey, you will understand exactly why astronomers gave one particular planet a title that no other world in the known universe currently holds: the most beautiful planet ever found. Why this one? out of more than 5,000 candidates. What makes a planet beautiful when most of them will never be touched by light fast enough to actually see in detail? And what does it say about us, about Earth, about the only blue world we have ever truly known, that out there, somewhere, an even more breathtaking blue is waiting in the dark? We will answer all of it, slowly, gently, one world at a time. But first, we need to understand something deeper than just numbers and discoveries. We need to understand how it is even possible to see a planet that human eyes can never reach. That is where our journey truly begins. Here is a question that sounds simple, but has no easy answer. How do you see something that is too small, too dim, and too far away to ever actually photograph? A star like our sun is, on a cosmic scale, almost unimaginably bright. A planet orbiting that star, even a large one, is roughly 1 billion times fainter. Trying to directly photograph a planet next to its star has been compared by more than one astronomer to trying to see a single firefly hovering directly in front of a lighthouse beam from thousands of miles away. So scientists had to become clever, patient, almost meditative in their methods. For decades before that first confirmed discovery in 1995, the search had been littered with false starts. Several earlier announcements of planets orbiting other stars, made in the 1960s and again in the 1980s, were later quietly retracted once follow-up observations failed to confirm them, the suspected signals turning out to be nothing more than instrumental noise, or the ordinary. Planetless wobble of a star's own outer layers. Each retraction was a small disappointment, but also, in its own way, a necessary lesson. The universe does not reward impatience. It rewards only careful, repeated, skeptical observation, checked and rechecked, until a signal can no longer be explained any other way. The most successful technique, the one responsible for the vast majority of exoplanet discoveries, doesn't try to see the planet at all. Instead, it watches the star. Picture a distant star, glowing steadily, its light traveling outward in every direction at once. Now imagine a planet, invisible to us, slowly circling that star in its orbit. At a certain point in that orbit, the planet passes directly between the star and our line of sight here on Earth. For a few hours, sometimes only minutes, that planet blocks a tiny, tiny fraction of the star's light. Not enough to notice with your eyes. Not enough to notice with an ordinary telescope, but enough for an extraordinarily sensitive instrument to detect a dip in brightness so small, so precise, that it can be measured in fractions of a single percent. That faint, repeating dimming is called a transit, and it was the discovery method behind the vast majority of confirmed exoplanets. But a single dimming, on its own, is not actually proof of anything. Stars flicker for all sorts of reasons that have nothing to do with planets. A faint background star drifting briefly into view along the same line of sight. A dark star spot, something like a sunspot, only on a distant star, rotating slowly into view and out again. Even tiny imperfections in the instrument itself can sometimes mimic the signal astronomers are searching for. So a second, independent confirmation was needed, and that confirmation came from a method even older than the transit technique, one astronomers call the radial velocity method, though it's more often described simply as the wobble. Here is the quiet secret hidden inside that name. We tend to picture a planet orbiting a star, as if the star sits perfectly still while the planet circles around it, like a marble orbiting a bowling ball. But that isn't quite accurate. In truth, both objects orbit a shared point of balance between them, their combined center of gravity. A star is so much larger than any planet that this shared point sits very close to the star's own center, but not exactly on it. As the planet swings around its orbit, the star itself is tugged into a small, slow, repeating wobble of its own. That wobble is too small to see directly, but it does something measurable. It very slightly stretches and compresses the wavelength of the star's light, first toward red, then back toward blue, in a steady, repeating rhythm. The same physical principle behind the changing pitch of a passing ambulance siren, just translated from sound into starlight. When astronomers detect both signals together, a periodic dimming from a transit and a periodic wobble of matching rhythm from radial velocity, they can be confident, beyond reasonable doubt, that a genuine planet, and not some trick of starlight, is responsible. It was this combination of patient, overlapping methods that allowed NASA's Kepler Space Telescope, launched in 2009, to change everything. For 4 uninterrupted years, Kepler stared at a single, fixed patch of sky near the constellation Cygnus, quietly monitoring the brightness of more than 150,000 stars at once, watching, waiting for the smallest possible flicker. By the time its primary mission ended, Kepler alone had contributed evidence for more than 2,000 confirmed exoplanets, and thousands more candidates still being verified today. Its successor, the Transiting Exoplanet Survey satellite, launched in 2018, took that same patient method and turned it outward across the entire sky rather than a single fixed patch, searching for planets around stars much closer and brighter than the ones Kepler had studied, including several of the very worlds we will visit together tonight. But here is where the story becomes more remarkable. From that single tiny dip in starlight, astronomers can calculate the size of the planet causing it. The deeper the dip, the larger the planet. The duration of the dip reveals how fast the planet is moving. The interval between dips reveals exactly how long that distant world takes to complete one full orbit around its star, its entire year, compressed into a number on a screen. And that was only the beginning, because once astronomers knew where to look, an even stranger possibility emerged. What if, during that brief transit, some of the star's light didn't just get blocked? What if some of it passed directly through the planet's atmosphere first? If a planet has an atmosphere, starlight filtering through those gases on its way to Earth would be subtly altered. Certain wavelengths would be absorbed by certain molecules, water vapor, methane, sodium, even more complex compounds, leaving a kind of cosmic fingerprint embedded directly inside the starlight itself. By carefully studying that fingerprint, spread out across a rainbow of wavelengths called a spectrum, scientists could determine, from trillions of miles away, what kind of air a planet might have. Whether it had clouds, whether it had water, whether it might, in theory, support something resembling life. This technique, called spectroscopy, became the closest thing astronomers had to actually visiting these worlds in person. A small number of planets, usually massive ones orbiting far from their stars, have even been captured through a third method entirely: direct imaging, using specialized instruments that physically block out the overwhelming glare of a parent star, the way you might cup your hand to shield your eyes from the sun, allowing the much fainter light of an orbiting planet to finally become visible. Later tonight, you'll meet a planet found exactly this way, one glowing with a color almost nobody expected. And a fourth method, rarer still, doesn't rely on a planet's own star at all. Sometimes, a planet's gravity can be detected by the way it bends and magnifies the light of a completely unrelated distant background star as it drifts briefly into alignment. A fleeting cosmic coincidence called gravitational microlensing. It is this method that would eventually reveal some of the strangest, loneliest worlds in tonight's entire journey. And then, in the final decade of this research, an entirely new kind of telescope rewrote the rules a second time, the James Webb Space Telescope. Launched in December 2021 and positioned nearly 1 million miles from Earth, was built with mirrors large enough and instruments sensitive enough to detect not just whether an exoplanet has an atmosphere, but to begin painting a genuine picture of what that atmosphere might look like, its temperature, its chemistry, even hints of its color. For the first time in human history, scientists were not just detecting distant worlds, they were beginning, faintly, gently, to actually see them. And it was during this new era of observation, armed with telescopes powerful enough to taste the chemistry of alien skies, that researchers stumbled upon something that none of their instruments were originally designed to find. A planet whose true color, once finally measured with enough precision, turned out to be something almost nobody expected. But before we travel to that particular world, we need to understand something else first, something that makes its eventual beauty even more striking by comparison. We need to see, with our own imagination, just how strange, how violent, and how utterly unlike anything on Earth most of these distant worlds actually are. Because the universe, it turns out, has an extraordinarily wide definition of what a planet can be. And the first world on our journey tonight will prove that almost immediately. 41 light-years from Earth, in the constellation Cancer, there orbits a star almost identical in size to our own Sun. To the naked eye, on a clear night, it would look like nothing more than a faint, unremarkable point of light. But circling that star, so close that its entire year lasts less than 18 hours, there is a planet that captured the imagination of the public almost the moment it was properly studied. Astronomers call it 55 Cancri e. At first glance, the numbers alone are strange enough. This is what scientists call a super-Earth, roughly twice the size of our planet and about 8 times its mass. It orbits its star at a distance of barely 1.5 million miles, compared to Earth's 93 million. To put that into a scale your mind can actually hold, if our sun were the size of a basketball sitting in front of you, this planet would be orbiting it at a distance you could cover in 2 or 3 steps. At that distance, temperatures on the planet's surface are estimated to reach somewhere between 3,200 and 4,900 degrees Fahrenheit. Hot enough to melt steel. Hot enough that the very concept of a surface, in the way we understand it on Earth, may not even apply in any normal sense. But the temperature alone isn't what made this planet famous. In 2012, a team of astronomers studying the chemical composition of 55 Cancri e's parent star noticed something unusual, an unexpectedly high ratio of carbon compared to oxygen. That ratio matters enormously because it determines what kind of minerals and compounds can form on a planet as it's born from the same cloud of gas and dust as its star. If a planet forms in a carbon-rich environment, instead of growing rocks made of the oxygen-rich silicates we have here on Earth, granite, basalt, quartz, it can instead form an interior dominated by carbon-based compounds. And under the right pressure, carbon can crystallize into something almost unbelievable. Diamond. Pause for a moment on the strangeness of that single word, sitting inside a sentence about planetary geology. On Earth, diamond is rare precisely because the conditions needed to form it, extreme pressure, extreme heat, locked deep within our planet's mantle, are difficult to reach and even harder to bring safely back to the surface without the crystal converting back into ordinary graphite along the way. On 55 Cancri E, by contrast, those same extreme pressures and temperatures may not be a rare hidden exception. They may simply be the normal, everyday condition of the entire interior, layer after layer, for the planet's entire existence. Based on this chemistry, several research teams propose that a significant portion of 55 Cancri E's interior, by some estimates as much as a third of the planet's entire mass, could theoretically be composed of crystallized carbon. Diamond, not as jewelry, but as bedrock, as mountains, as the literal structure of an entire world. Try for a moment to actually picture this. Not a sparkling gem the size of a ringstone, but an entire planetary interior, layers deep, glittering under pressures and temperatures no human instrument could survive. Geological diamond, formed not for beauty, but simply because the universe, in that particular corner of space, happened to build its planets out of carbon instead of oxygen. If you could somehow stand on a viewing platform safely above this world, which, given the temperatures involved, would require technology that does not yet exist, the light from its nearby star would refract and scatter through an atmosphere unlike anything in our solar system, possibly reflecting off crystallized surfaces in ways that have never been witnessed by any living eye. 55 Cancri E was not discovered all at once. It was first detected in 2004 through the radial velocity wobble of its star, long before anyone knew its true size. It would take another 7 years, until 2011, before astronomers finally caught it transiting directly in front of its star, allowing them to measure, for the first time, its actual physical size, and from there, combined with the earlier mass measurement, its density. That density was the very clue that first hinted at a world unlike anything in our own solar system. It also isn't alone. The star it orbits, simply known as 55 Cancri, hosts at least 4 other known planets, ranging from a roughly Saturn-sized gas giant to several other smaller worlds, all swinging around the same star in a quiet, layered system that has been studied for longer than almost any other exoplanetary system known to science. 55 Cancri E is simply the innermost, the fastest, and by far the strangest of this entire planetary family. And there is one more layer of mystery still being investigated. While many close-in planets like this one are assumed to be tidally locked, with one side permanently facing their star, some researchers studying 55 Cancri E's heat distribution have proposed it may instead be caught in a different, rarer kind of gravitational relationship, something closer to a spin-orbit resonance, similar to the way our own Mercury rotates exactly 3 times for every 2 trips it makes around the Sun. If true, This planet would not have a single permanent day side and night side at all, but a far stranger, slowly shifting pattern of sunrise and sunset, repeating across a calendar that has no equivalent anywhere in our solar system. Later research has complicated this original diamond planet idea. More recent studies, using improved measurements of the star's chemistry and updated models of the planet's interior, suggest the carbon ratio may not be quite as extreme as first proposed, and some scientists now believe the planet may be covered not in solid diamond, but in something almost as strange, an ocean of molten lava, glowing and shifting across its scorched day side, while the far side remains locked in permanent frozen darkness. But here is where the story becomes even stranger, because in 2016, when researchers used the Spitzer Space Telescope to study the planet's temperature across its full orbit, they discovered something that didn't fit any simple model at all. The hottest point on the planet wasn't where it should have been, directly facing the star. Instead, the heat appeared to be shifted, as though something was actively redistributing it across the surface. The leading explanation? Vast plumes of gas, possibly silicate vapor, possibly something else entirely, erupting from the molten surface and being swept around the planet by extreme winds, carrying heat to regions that should, by simple physics, remain in cold and permanent shadow. In other words, 55 Cancri may have something resembling weather. Except instead of rain and wind in any familiar sense, the storms on this world may be made of vaporized rock, condensing and falling as molten droplets across an alien horizon glowing dull orange under a sky thick with mineral haze. A world that might be lava ocean, might be diamond bedrock, might be both, in different eras, in different layers, in different unexplored corners of its surface. And we still don't know for certain which it is. That uncertainty, that unanswered question hanging over one of the most famous exoplanets ever discovered, is itself a kind of quiet lesson for tonight's journey. The universe does not always offer clean, simple answers. Sometimes the most honest thing science can say about a breathtaking alien world is simply, we are still looking, we are still wondering, we are still, patiently, gathering more light. Even the James Webb Space Telescope, with all its extraordinary sensitivity, was turned toward this planet in the years following its launch, hoping finally to settle the question of what kind of atmosphere, if any, could possibly survive at such extreme temperatures. Early results suggested faint traces of an atmosphere containing carbon dioxide and carbon monoxide, a thin secondary layer of gas, possibly replenished continuously by volcanic outgassing from the molten or semi-molten surface beneath it. Even this newest, most powerful eye ever pointed toward the sky could only deepen the mystery, rather than resolve it completely. And as fascinating as 55 Cancri is, it is far from the only world in this region of strangeness. Because not far away, in cosmic terms, there is a planet undergoing something even more dramatic than scorching heat or shifting storms of vaporized rock. There is a planet that is quite literally being eaten alive by its own star. 600 light-years from Earth, in the constellation Auriga, there is a planet that astronomers describe, almost without exception, using the language of slow, inevitable tragedy. Its name is WASP-12b. Discovered in 2008, this gas giant orbits its host star at a distance so close, roughly 2 million miles, compared to Earth's 93 million, that it completes an entire orbit, an entire year, in just over one Earth day. The discovery came from the wide-angle search for planets, a network of small automated cameras stationed in observatories across two hemispheres, continuously monitoring the brightness of hundreds of thousands of stars at once, night after night, in the patient hope of catching exactly this kind of signal, a brief, regular dimming as a planet crossed in front of its star. WASP-12b's was simply one of the first truly extreme examples this growing global search managed to catch. At that distance, the gravitational forces at play are no longer gentle. They are violent. Tidal forces from the star stretch the planet's shape from a sphere into something closer to an egg, distorted permanently by the relentless pull of gravity acting unevenly across its bulk. But the shape of the planet was only the first clue that something deeply unusual was happening here. When astronomers studied WASP-12b's atmosphere more closely, they discovered it was surrounded by an enormous, extended envelope of gas, far larger than the planet itself, slowly streaming away from the planet's surface and spiraling, almost gracefully, toward its parent star. Astronomers have a name for what is happening here: Roche lobe overflow. Every planet has an invisible boundary around it, a region of space where its own gravity remains dominant over its stars. Cross that boundary, and the star's gravity simply wins. For most planets, including every planet in our own solar system, that boundary sits comfortably far beyond the planet's actual surface, with plenty of room to spare. But WASP-12b's orbits so punishingly close to its star that its outer atmosphere has begun to swell past that invisible line entirely, like water finally spilling over the rim of an overfull glass, except here, what spills over is not poured back, but lost forever, drawn instead into a long glowing stream falling toward the star. The planet, in other words, is losing its own atmosphere. Continuously, irreversibly, picture it like this. Imagine a small moon of ice, slowly melting as it drifts too close to a bonfire, leaving behind a faint, glowing trail of vapor that drifts toward the flame, never to return. Except here, the ice is an entire planetary atmosphere. The bonfire is a star roughly the size of our own sun, and the trail of vapor stretches for millions of miles, forming what astronomers have described as a vast, glowing disk of material being slowly funneled from planet to star. Researchers estimate that WASP-12b's is losing roughly 6 billion kilograms of its own mass every single second. Numbers this large rarely mean much on their own, so it helps to slow down and hold this one for a moment. 6 billion kilograms is roughly the combined mass of every car currently registered in a large country, vanishing from a single planet every single second, without pause, without rest, for as long as the planet has existed in this configuration. And still, after all of that loss, sustained for millions upon millions of years already, the planet remains massive enough, even now, to be clearly studied from 600 light-years away. It sounds catastrophic, and it is. But here is the strange comfort hidden inside that number. Even at that almost unimaginable rate of loss, the process is so gradual on a cosmic timescale that the planet is expected to survive, slowly shrinking, for roughly another 10 million years before being fully consumed. 10 million years of a planet quietly, continuously dissolving into its own star. Long enough that, by the time it finally disappears entirely, entire new species could rise and fall on a world like Earth, unaware that somewhere, deep in the constellation Auriga, a planet was finishing a death that began long before any of them were born. But the most visually striking detail about WASP-12b's isn't its slow destruction at all, it's its color. When researchers used the Hubble Space Telescope to measure the precise wavelengths of light reflected from the planet's atmosphere, they discovered something that initially seemed almost impossible. The planet appeared to be reflecting almost no light back into space whatsoever. Less than 1% of the starlight hitting it was being reflected. In practical terms, this means WASP-12b's is one of the darkest planets ever measured, a world so efficient at absorbing nearly all visible light that, if you could somehow view it safely from a nearby vantage point, it would appear almost as a black silhouette, glowing only faintly from the heat trapped within its own scorched, distorted atmosphere, an inky void carved directly into the bright, star-soaked backdrop of space, a planet so hot its clouds cannot form normally, so close to its star that it is being consumed atom by atom, and so dark that it absorbs almost every photon of light that touches it. And yet, despite all of this, despite being, by almost every definition, one of the most violently inhospitable places in the known universe, WASP-12b's atmosphere produces something unexpectedly delicate when examined by spectroscopy, faint signatures of water vapor and carbon-based molecules drifting briefly through a sky that exists in cosmic terms on borrowed time. It is a world defined entirely by contradiction. Dark, yet glowing faintly with trapped heat. Dying, yet stable enough to have likely existed in roughly its current state for a very long time before astronomers ever turned their instruments toward it. Violent and tragic in its slow destruction, yet somehow, in its strange way, beautiful, not in spite of its fate, but because of it. There is something quietly human about a world like this, even though nothing about it could ever support human life. A reminder, perhaps, that everything in the universe, planets, stars, even galaxies themselves, exists on some kind of timeline. Nothing is permanent, not even the largest, most massive objects we can observe. WASP-12b's is far from alone in this slow, doomed dance. Astronomers have since identified several other extreme ultra-close gas giants undergoing similar fates, worlds with names like Kelt 9b, orbiting a star so hot and so close that its dayside temperature exceeds even some stars, and WASP-103b, which appears to be losing mass into a similarly glowing trail of escaping atmosphere. Each one is a slightly different variation on the same quiet tragedy, a planet that simply formed, or wandered, too close to the gravity that gave its star such overwhelming power in the first place. Surveys like TESS continue actively searching for more of these doomed worlds today, in part because each new example helps refine the models astronomers use to predict exactly how quickly a planet like this should lose mass, and exactly how long it has left. Every additional discovery is, in a strange sense, another data point in an ongoing galaxy-wide study of slow planetary death, one that, fittingly, can only be conducted by patiently observing worlds none of us will ever see vanish completely, since the process unfolds across timescales many, many times longer than all of recorded human history combined. But if WASP-12b shows us a planet being slowly consumed, Our next destination shows us something almost the opposite. A world whose violence isn't slow and gradual at all, but immediate, constant, and almost impossible for the human mind to fully picture. A planet where it does not simply rain, it rains liquid iron. 640 light-years away, in the constellation Pisces, orbits a planet that sounds, at first, like something invented for a piece of science fiction. Its name is WASP 76b, and in 2020, astronomers using the European Southern Observatory's Very Large Telescope in Chile discovered something about its atmosphere that had never been observed on any planet before, anywhere. The discovery came from an instrument called espresso, a spectrograph sensitive enough to split a star's incoming light into thousands of individual wavelengths, searching for the precise chemical fingerprints hidden within it. Pointed at WASP 76b during a transit, it picked up something unusual almost immediately, and the team spent months double-checking their data before they trusted what they were seeing. Like several of the worlds we've already visited tonight, WASP 76b is a gas giant locked in an extremely close orbit around its star. So close that. Just like our own moon always shows the same face to Earth, this planet always shows the exact same hemisphere to its sun. One side remains in permanent, blazing daylight. The other remains in permanent, eternal night. On the day side, temperatures climb above 4,000 degrees Fahrenheit, hot enough that heavy metals, elements that remain locked safely inside solid rock on a planet like Earth, instead exist as vapor, drifting freely through the atmosphere like an invisible gas. Iron vapor. But here is where the story takes its first genuinely strange turn. As powerful winds, among the fastest ever detected on any planet, reaching speeds of several thousand miles per hour, sweep this iron-saturated atmosphere from the scorching day side toward the eternal night on the opposite hemisphere, something remarkable happens to the temperature along the way. It drops dramatically. And as the iron vapor cools while crossing into the planet's permanent darkness, it does something that, as far as astronomers can tell, has never been directly observed happening on any other known world. It condenses. It turns back into liquid metal. To put those wind speeds into a scale the mind can actually hold, the fastest hurricane ever recorded on Earth produced sustained winds of roughly 200 miles per hour, a force capable of leveling entire buildings. The winds carrying iron vapor across WASP 76b move at speeds many times faster than that, fast enough to cross the distance of an entire continent in the time it takes to finish a single, slow breath. And then, pulled by gravity, it falls. Rain made of liquid iron, falling silently through the permanent night side of an alien gas giant, vanishing into clouds and depths that no telescope has ever been able to fully penetrate. Try for a moment to actually hold this image in your mind. Not metaphorical rain, not a poetic description meant to sound dramatic. Actual liquid iron, falling from actual clouds, condensing out of an atmosphere hot enough on one side to vaporize metal, and cold enough on the other to turn that same metal back into droplets that fall like waterfalls here on Earth. It is one of the most genuinely alien weather systems ever detected in the known universe, and yet it follows the exact same basic physical principle as a rainstorm over your own home. Heat, evaporation, movement, cooling, condensation, Fall. The same laws of physics that govern a quiet rain shower outside your window here on a peaceful Earth evening are also responsible for an iron monsoon sweeping endlessly across the permanent dusk line of a planet 640 light-years away. There is something almost comforting in that thought, isn't there? That the universe, however strange, however violent, however far beyond our direct experience, still follows patterns, still follows rules, the same rules, often, that quietly govern our own small blue world. It's worth remembering, too, that this entire iron weather system depends on something extraordinarily fragile, the planet's permanent tidal lock, holding one face eternally toward the star and one eternally away. If WASP 76b ever lost that lock, through some unlikely gravitational disturbance from a passing object or some slow change deep within its own structure, its entire iron cycle would likely collapse along with it. Without a permanent night side cold enough to force condensation, the iron would simply remain vapor, drifting endlessly through a sky that would never again produce its strange, metallic rain. But WASP 76b held one more surprise. Researchers also detected something unusual in the chemical signature of the planet's atmosphere, an asymmetry between its morning and evening edges as it transits in front of its star. The signatures of iron were strong on one side and strangely faint on the other, exactly the pattern you would expect if iron were being vaporized on the day side. Swept around the planet by ferocious winds, and then quietly disappearing, condensing, falling, vanishing, before it ever reached the morning side to be vaporized once again. In other words, scientists weren't just theorizing about iron rain, they were watching its evidence, written directly into the chemistry of starlight passing through an alien sky, every single time the planet crossed in front of its star. WASP 76b also turned out not to be entirely alone in this strange behavior. Follow-up studies of other ultra-hot gas giants, including a similarly extreme world called WASP 21b, have detected signatures of other vaporized metals drifting through their atmospheres as well, including titanium and vanadium oxide, hinting that exotic metallic weather may be a far more common feature of these scorching worlds than anyone initially expected. WASP 76b simply happened to be the first one observed clearly enough to catch the iron in the act of actually falling. Picture the boundary line on this planet, the narrow twilight strip separating eternal day from eternal night, not as a sharp edge, but as a slow, glowing frontier, hundreds of miles wide, where scorching iron vapor drifting in from the blazing day side finally cools just enough to condense, falling as fine, glittering rain into a darkness it will never leave, vanishing into clouds that have never once been touched by sunlight, a world where metal falls like water, a world locked permanently between blinding day and endless night. A world whose extreme, violent beauty is written not in poetry, but in the spectral lines of starlight, measured patiently across hundreds of light years of empty space. Consider, for a moment, the entire water cycle that quietly sustains every living thing on Earth. Ocean water warmed by sunlight, rising invisibly as vapor, drifting on the wind, cooling into clouds, and finally returning as rain to feed rivers, forests, and fields. It is a cycle so familiar that most of us rarely think about it consciously at all. WASP 76b runs through the same basic four-step cycle: evaporation, transport, cooling, return. except every single step happens to a substance that on our world makes up the core of our planet rather than its sky. Iron, not water, plays the leading role. And if a planet can rain iron, you might begin to wonder what else the universe has quietly hidden in its endless catalog of strange and distant worlds. The answer, it turns out, leads somewhere far gentler and far more mysterious, because not every distant world is defined by fire and metal. Some of the most fascinating planets ever found are defined instead by something achingly familiar: water. In our own solar system, water is treated almost like a treasure. We search for it on Mars in the form of ancient, dried-up riverbeds. We search for it beneath the icy crusts of Europa and Enceladus, moons of Jupiter and Saturn, hoping that hidden oceans might somehow, somewhere, support something alive. But roughly 200 light-years away, in the constellation Ophiuchus, there orbits a small, unassuming planet that may answer a question astronomers have been asking for decades. What happens when an entire world becomes, almost entirely, water? Its name is GJ 1214b, discovered in 2009, and it belongs to a category of planet that doesn't exist anywhere in our own solar system. A mini Neptune, roughly 2.5 times the size of Earth, orbiting a small, dim, red dwarf star so closely that its entire year lasts just 38 hours. When researchers first studied this planet's density, calculated by carefully measuring both its size and its mass, they were puzzled. The number that emerged from their calculations didn't match a rocky planet like Earth, and it didn't match a gas giant like Jupiter either. It fell somewhere strange in between. The leading explanation, refined over more than a decade of follow-up research, suggests this planet may possess an enormous, deep layer of water, not in the small, thin oceans we have here on Earth, but a vast, planet-spanning layer of water, dozens or even hundreds of miles deep, compressed under such extraordinary pressure and heat that deeper down, it may not behave like ordinary water at all. At those depths, under pressures many thousands of times greater than anything found in Earth's deepest ocean trenches, water is theorized to enter exotic states that don't exist naturally anywhere on our own planet, forms sometimes nicknamed supersonic ice, where the water molecules remain locked in a rigid, crystalline structure, like ice. Even while individual hydrogen atoms move freely through that structure, behaving more like a liquid or even, in some models, like a strange kind of electrical conductor. In other words, ice that conducts electricity. Solid water, behaving partly like a flowing liquid, deep beneath the visible clouds of an alien world. To imagine pressures of that magnitude, picture the deepest point of Earth's oceans, the Mariana Trench, nearly 7 miles down, where the crushing weight of the water above is already enough to instantly destroy an unprotected human body. Now imagine continuing downward, mile after mile, for hundreds of additional miles beyond that point, the pressure climbing higher and higher with every step, until water itself, the same substance filling a glass on your nightstand, begins behaving like nothing found anywhere in your ordinary experience. Try to picture it. Above, a thick, hazy atmosphere, likely shrouded in clouds, scattering the dim red light of its small parent star into a perpetual, soft twilight. Below that haze, hundreds of miles of compressed water, first liquid, then gradually transforming, deeper and deeper, into something that exists at the very edge of our scientific understanding of matter itself. A planet that may be, fundamentally, an ocean. Not an ocean with a shore, the way we picture oceans on Earth, lapping gently against a beach beneath a familiar sky, but an ocean without any edge at all. A world where water simply is the world, all the way down, layer after layer, until pressure and heat transform it into something almost unrecognizable. This idea that some exoplanets might be almost entirely composed of water in increasingly exotic states opened an entirely new category of world for astronomers to search for, so-called water worlds or ocean planets. In 2017, this search gained a particularly compelling target when astronomers confirmed a system of 7 roughly Earth-sized planets orbiting a small, dim red dwarf star called TRAPPIST-1, just 40 light-years away, remarkably close, in cosmic terms, almost a neighbor. Several of these 7 worlds orbit within or near their star's so-called habitable zone, the narrow range of distance where temperatures might allow liquid water to exist on a planet's surface rather than freezing solid or boiling away entirely. Follow-up studies using the James Webb Space Telescope have continued investigating whether any of these 7 worlds might retain a substantial atmosphere at all, given how violently active small red dwarf stars can be toward any planet orbiting close enough to stay warm. Around the same time, researchers studying planets like GJ1214b proposed a more specific category within the broader ocean planet idea, a class of world they named Hycean, combining the words hydrogen and ocean, describing a planet with a deep, global liquid water ocean sealed beneath a thick, hydrogen-rich atmosphere. Such a world, if it exists in just the right configuration of temperature and pressure, could in theory maintain comfortable, almost temperate ocean conditions far below its hazy clouds, even while orbiting closer to its star than Earth orbits the Sun. Simply because that thick atmospheric blanket traps and regulates heat in ways no rocky, airless world ever could. And the search for such a world didn't stop with GJ1214b. In 2023, a much closer planet, K218b, orbiting a red dwarf star just 120 light-years from Earth, became the focus of intense excitement when the James Webb Space Telescope detected something unexpected in its atmosphere. Signatures consistent with methane and carbon dioxide, but a notable absence of ammonia. A pattern that some researchers suggested could indicate a deep, planet-wide ocean lying beneath a hydrogen-rich atmosphere. Even more intriguing, in that same set of observations, scientists detected a tentative, still unconfirmed signature of a molecule called dimethyl sulfide on Earth, a compound produced almost exclusively by living organisms, particularly marine phytoplankton drifting in our own oceans. It's important to pause here gently and be honest about what this does and does not mean. A tentative signature is not proof. Many scientists have urged caution, noting that the detection requires further confirmation and that non-biological processes might also explain the same chemical signal. K218b's true nature is still debated. Some studies have even suggested it might be a sub-Neptune with a thick, scorching hydrogen atmosphere rather than the cooler, watery Hycean world first proposed. But the very fact that such a question could be asked at all The very fact that astronomers, sitting in offices and observatories here on Earth, found themselves seriously discussing the possibility of an ocean and the possibility of life on a planet over 100 light-years away says something remarkable about how far this search has come. A few decades ago, we didn't know if any planets existed beyond our own solar system at all. Now, we are gently, carefully, scientifically asking whether some of those planets might have oceans, and if they have oceans, what or who might be quietly living inside them. We don't have an answer to that question yet. We may not have one for a very long time. But the question itself, hanging softly in the dark over a planet we can never visit, is part of what makes this entire search feel less like science, sometimes, and more like a kind of patient, cosmic poetry. Dozens of similar small, dim red dwarf stars are currently being monitored by ongoing surveys, each one searched patiently for the same kind of telltale transit, the same kind of revealing atmospheric fingerprint, in the hope of finding more candidates for this strange, hopeful new category of ocean world. Most candidates, when finally studied closely enough, turn out to be something less dramatic than first hoped, a thick, scorching hydrogen envelope rather than a gentle, life-friendly sea. But the search continues precisely because, every so often, a candidate survives that closer scrutiny a little longer than expected, keeping the door to possibility open just a little wider than it was the day before. And speaking of darkness, our next destination takes that idea to its most extreme conclusion. Because while GJ1214b and K218b may be shrouded in hazy, watery clouds, there exists a planet so dark, so absorbing, so utterly without reflected light, that it makes even the deep void of space around it look bright by comparison. 750 light-years from Earth, in the constellation Draco, the Dragon, there orbits a gas giant that holds a strange and almost paradoxical record. Its name is TRES 2b, and it is, according to measurements taken by the Kepler Space Telescope, the darkest planet ever discovered. The planet's existence was actually known before Kepler ever launched, first identified through ground-based transit surveys in 2006. But it was Kepler's extraordinary sensitivity, originally designed to find planets by their dimming transits, that allowed astronomers to attempt something far more delicate years later, measuring not the dip caused by the planet blocking its star, but the far subtler, far fainter change in total brightness caused by the planet's own dim, reflected light disappearing and reappearing as it swung around its orbit. It was in effect the same color measuring technique used elsewhere on tonight's journey, just pushed to detect something far closer to nothing at all. When astronomers speak of a planet's albedo, they're describing how much light it reflects back into space, on a simple scale where 1 represents a perfect mirror reflecting all light, and 0 represents perfect, total darkness, absorbing everything. Earth's albedo, thanks to clouds, oceans, and ice, sits at roughly 0.3, meaning we reflect about 30% of the sunlight that reaches us, which is part of why our planet appears as such a bright, vivid blue marble when viewed from space. TRES 2b's albedo, measured carefully by tracking the subtle changes in light as the planet orbits its star, was found to be lower than 1%. Less than 1% of all light reaching this planet is reflected. The other 99% or more simply vanishes into its atmosphere, absorbed completely, leaving almost nothing behind. For comparison, this makes TRES-2b darker than coal, darker than the blackest acrylic paint produced for human use. Some researchers have even compared its darkness to vantablack, a human-engineered material made of carbon nanotubes so densely packed that it absorbs more than 99.9% of visible light, used by scientists and artists specifically because it can make a solid, three-dimensional object look like a flat, painted silhouette, or, in some cases, like a hole cut directly into reality itself. TRES-2b, formed entirely by natural processes hundreds of light-years away, with no engineer, no laboratory, and no human hand involved, appears to rival that same extreme darkness purely through the chemistry of scorching, metal-laced gas. Why would an entire planet be so completely, efficiently dark? The leading explanation involves the planet's extreme heat. TRES-2b orbits its star at a distance of just 3 million miles, completing a full orbit in roughly 2.5 days, and surface temperatures are estimated to exceed 1,800 degrees Fahrenheit. At those temperatures, the chemical compounds that might otherwise form bright, reflective clouds, the kind of pale ammonia-based clouds we see on Jupiter, for example, simply cannot exist. They would be instantly vaporized. Instead, researchers believe the planet's atmosphere may contain compounds like vaporized sodium, potassium, and possibly gaseous titanium oxide, substances that, rather than reflecting light, absorb it almost completely, converting it instead into heat. The result is a planet that doesn't glow with reflected starlight at all. If you could observe it from a safe distance, against the backdrop of space, it would appear less like a planet and more like a perfectly circular void, a hole cut directly out of the star field behind it, outlined faintly, perhaps, only by a dim, dull red glow from its own internally trapped heat, similar to the way a dying coal in a fireplace continues to glow long after the flames have gone out. A planet, in other words, that is almost defined by its absence, by what it refuses to give back to the universe around it. There's a strange irony tucked inside this discovery. Astronomers were only able to measure TRES-2b's extraordinary darkness because of how much light its own star provides, the same intense starlight responsible for the planet's scorching heat is precisely what makes its almost total absorption so measurable, so striking, so scientifically certain. The very thing that makes this world so inhospitable is also the thing that allowed us, 750 light-years removed from its surface, to know it exists at all. There is something quietly unsettling about that idea, and something quietly beautiful about it too. We tend to associate beauty with brightness, with light, with color, with things we can clearly see. But TRES-2b suggests something different, that even total darkness, observed and measured carefully enough, can become its own kind of remarkable, its own kind of strange wonder. It also raises an interesting question that researchers have continued to investigate in the years since TRES-2b's discovery. If a planet can be almost perfectly dark, could the opposite also exist? Could there be a planet somewhere in the galaxy so reflective, so mirror-like, that it shines almost as brightly as a small star? The search for such a planet continues. Several candidates with unusually high albedos have been proposed over the years, including small, icy worlds capable of reflecting more light than Earth itself. One notable example, Kepler 7b, appears to be covered in high, bright clouds, likely composed of silicate or aluminum oxide particles, reflecting enough starlight back into space to make it one of the most mirror-like gas giants ever measured, sitting at almost the exact opposite end of the brightness scale from TRES 2b. But even Kepler 7b, for all its reflective brilliance, has never rivaled the sheer, record-breaking emptiness of TRES 2b's darkness on the opposite extreme. More recently, astronomers have proposed using the James Webb Space Telescope to study TRES 2b's full phase curve, tracking its brightness continuously across an entire orbit rather than at a single moment, hoping to confirm whether its darkness truly is as uniform and total as the original measurements suggested, or whether faint, localized bright patches might exist somewhere within its scorching, light-swallowing atmosphere, hidden until an instrument sensitive enough finally takes the time to look closely enough to find them. A planet of near-total darkness. A planet that may rain liquid metal. A planet slowly being consumed by its own star. A planet that might be made partly of diamond, and a planet that might be made almost entirely of ocean. By now, you may be starting to sense a pattern in tonight's journey, a quiet, recurring lesson hiding underneath each new world we visit. The universe does not seem to repeat itself. Every planet we have studied so far operates by its own unique balance of heat, chemistry, gravity, and light, producing combinations and outcomes that no two worlds seem to share. And our next destination continues that pattern in an entirely different direction, not through extremes of darkness or heat, but through something far softer. A planet that glows, faintly and strangely, in a color almost no one expected to find drifting through the void of deep space. Pink 57 light-years from Earth, in the constellation Virgo, there orbits a planet discovered through a method completely different from almost everything we've discussed so far tonight. Most of the worlds we visited were found indirectly, through tiny dips in starlight, through faint gravitational wobbles, through careful, patient mathematics performed on data that never directly showed a planet at all. But GJ504b, discovered in 2013, was something rarer. It was directly imaged, photographed in a very real sense by a specialized instrument on the Subaru telescope in Hawaii, designed specifically to block out the overwhelming glare of a parent star and reveal the much fainter light of any planets orbiting nearby. And when astronomers finally captured that faint point of light, separate from its star, they discovered something almost nobody expected. The planet appeared to glow with a distinct magenta-pink hue. To understand why, you have to picture this planet not as it exists today, fully formed and settled, but as it existed at the moment it was observed, relatively young, in cosmic terms. At roughly that time, still slowly cooling down from the immense heat of its own formation. Massive planets like GJ504b, initially estimated to be roughly 4 times the mass of Jupiter, generate enormous amounts of internal heat as they coalesce out of the same swirling disk of gas and dust that gave birth to their star. In the earliest millions of years of their existence, before that internal heat has had time to fully radiate away into space, these young giant planets can glow with their own thermal light, almost like a dim, cooling ember, independent of any sunlight reflecting off their surface. But here, the story took an unexpected turn of its own. The original mass estimate for GJ 504b depended heavily on the calculated age of its parent star, and estimating a star's exact age, even today, remains one of the more difficult tasks in all of astronomy. When a follow-up study in 2020 revised the star's age to be significantly older than first thought, the planet's estimated mass dropped dramatically as well. From 4 times the mass of Jupiter down to somewhere closer to Jupiter's own mass, possibly placing it right at the blurry, debated boundary between planet and a smaller class of failed star called a brown dwarf. The pink glow remained exactly the same. Only humanity's understanding of what, precisely, was producing it had to be quietly rewritten. It serves as a gentle reminder that even a planet captured directly in a photograph, its light unmistakably real, is never fully finished being studied. The image stays the same. Our understanding of it keeps evolving, sometimes for years, sometimes for decades, as our tools and our models slowly improve. Capturing that image at all required extraordinary technical precision in the first place. The Subaru telescope's instrument used a coronagraph, a small, precisely shaped mask designed to block the blinding light of the parent star itself, paired with adaptive optics, a system of rapidly adjusting mirrors that corrects, many times per second, for the subtle blurring caused by Earth's own turbulent atmosphere. Only by combining both technologies together could astronomers finally separate the star's overwhelming glare from the impossibly faint pink light of the planet drifting beside it. GJ 504b, at an estimated temperature of around 460 degrees Fahrenheit at the time it was observed, relatively cool for a planet of its type, but still glowing with residual heat from its formation, produced a spectrum of light that researchers described as a striking, deep magenta or pink color, unlike the more familiar reddish-brown hues typically associated with brown dwarfs and young gas giants of similar mass. Picture a planet glowing softly in the dark, not reflecting the light of a distant sun, but radiating its own faint inner color, the lingering warmth of its own violent birth slowly fading across millions of years, like the last visible embers of a fire that was lit before the first humans ever walked the earth. It is a strange, quiet kind of beauty that has nothing to do with reflected sunlight, and everything to do with a planet's own internal history, its own past, its own slow, patient cooling, visible to us today only because we happen to observe it during this particular, fleeting window in its multi-billion-year existence. In several 100 million years, as GJ 504b continues to cool, that pink glow will fade entirely, leaving behind a planet that, like most gas giants we know, would likely appear simply dark and cold to any future observer with the technology to look. Several 100 million years is a span of time almost impossible to relate to a single human life. It is roughly the same length of time that has passed since the first complex animals crawled out of Earth's oceans onto dry land. By the time GJ 504b's glow finally fades to nothing, an entire comparable stretch of evolutionary history could unfold somewhere else, on some other fortunate world, beginning, perhaps, with nothing more than simple cells drifting in shallow water, and ending, perhaps, with something curious enough to build its own telescope and look outward into the dark. We were lucky enough, or perhaps it's more accurate to say humanity was patient enough, to be alive during the precise sliver of cosmic time when this particular planet still carried a visible memory of its own creation. That thought alone is worth sitting with for a moment. Every glowing pink photon captured by that telescope in Hawaii had traveled 57 years through the vacuum of space, only to arrive at exactly the right moment, in exactly the right place, to be captured by an instrument built by human hands, studied by human minds, shared with people like you, sitting somewhere quiet, listening to a story about a planet none of us will ever visit. There is something deeply moving in that chain of events, if you allow yourself to sit with it. And it raises a quieter, more personal kind of question. How many other worlds, right now, are glowing faintly somewhere out there, carrying some unique signature of color or light that no human telescope has yet been positioned, or built, or patient enough to capture? We will likely never know most of them. The universe is simply too vast, too old, too full of secrets for any single civilization to uncover more than a fraction of what exists. Even our own technology is improving quickly enough that planets like GJ 504b are expected to be studied in far greater detail in the coming years, as newer space telescopes with even larger mirrors and even more sensitive instruments come online, each one capable of directly imaging fainter, smaller, and more distant worlds than the generation before it. The pink glow we caught a glimpse of in 2013 may, before long, be joined by dozens of other faint, glowing companions scattered across the sky, simply waiting for an instrument patient enough and powerful enough to finally notice them, too. But every so often, as with GJ 504b's pink glow, as with the iron rains of WASP 76b's, as with the possible diamond depths of 55 Cancri E, we get lucky. We catch one. We see, however briefly, however incompletely, a world that was always there, waiting quietly in the dark for someone, somewhere, to finally look in exactly the right direction. And speaking of unlikely arrangements in the dark, our next destination introduces something that, until recently, existed almost entirely in the realm of fiction. A planet with not one sun in its sky, but two. In 1977, a young filmmaker imagined a desert planet orbiting two suns, its twin shadows stretching long across an alien sand dune as a young hero gazed toward the horizon, dreaming of a life beyond his small, dusty world. For decades, that image, two suns setting together in a single sky, remained one of the most beloved pieces of pure imagination in popular culture. Then, in 2011, it stopped being imaginary. Roughly 200 light-years from Earth, in the constellation Cygnus, astronomers using the Kepler Space Telescope confirmed the existence of a planet they named Kepler 16b, orbiting not one star, but two, a pair of stars locked in a close binary orbit around each other, with the planet circling both of them together in a wider, stable orbit around their shared center of mass. Astronomers call this kind of world a circumbinary planet, and Kepler 16b became the first one ever confirmed beyond reasonable scientific doubt. Detecting it required an unusual combination of careful observation, rather than watching for a simple repeating dip in starlight from a single star. Astronomers had to track the subtle overlapping eclipses of two stars passing in front of each other, and then notice an additional, smaller, less regular dimming caused by something else entirely, A third, much fainter shadow crossing the system at irregular intervals, betraying the presence of a planet whose orbital timing shifted slightly with every pass, exactly as you would expect from a world being tugged gently between two competing centers of gravity rather than orbiting one fixed star. To understand just how delicate and surprising this discovery was, you have to appreciate how chaotic binary star systems can be. Two stars, orbiting closely around each other, create a constantly shifting, constantly changing gravitational field. For a long time, many astronomers assumed that planets simply could not form or could not survive for long in such an unstable environment, pulled and tugged unpredictably between two competing centers of gravity. And yet Kepler 16b proved that assumption wrong. The planet itself is a cold, gaseous world, roughly the size of Saturn, orbiting its two parent stars from a safe enough distance to maintain a long-term, stable orbit, a delicate cosmic balancing act that nature somehow worked out entirely on its own, without any guidance, without any plan, simply through the patient mathematics of gravity, acting consistently over millions of years. Researchers have since run extensive computer simulations testing exactly how stable orbits like this one can remain over truly long timescales, millions, and in some models, billions of simulated years. The results suggest that while the precise zone for a stable circumbinary orbit is narrower than for a planet orbiting a single star, it is far from impossibly rare. Once a planet settles into the right distance from its two parent stars, the same gravitational mathematics that initially seemed too chaotic to support a stable world can, instead, lock that orbit into place for the remainder of the system's natural life. Picture standing on the surface of a world like this. Though the temperatures here, hundreds of degrees below freezing, would make that an impossibility for any unprotected human visitor. Above you, not one sun crawling slowly across the sky, but two, one larger and slightly more orange in color, the other smaller, dimmer, and noticeably more yellow, like our own sun's slightly fainter sibling. Depending on the time of this world's long, complex year, those two stars would sometimes appear close together in the sky, nearly overlapping, casting a single blended light across the landscape. At other points in the orbit, they would drift apart, creating two distinct shadows for every object on the surface, stretching outward at different angles, slowly shifting throughout an alien day far stranger than anything experienced on Earth. Imagine, for a moment, what a single season might feel like on such a world if it had a surface capable of registering the passage of time at all. Not simply warmer or colder as the seasons shift on Earth, but a slow, rhythmic change in the very geometry of light and shadow themselves. Twin suns drawing closer together in the sky for months at a time, merging into one bright source, then gradually separating again, each cycle a quiet, repeating reminder that this world belongs to two suns at once, never fully to either one alone. Since Kepler 16b's discovery, astronomers have confirmed several more circumbinary planets, each one slightly different, each one offering a new variation on the same extraordinary theme. Some orbit two stars that are nearly identical in size and temperature, creating skies with twin suns of nearly matching color and brightness. Others orbit pairs of stars so different from each other, one large and bright, one small and dim, that the resulting skies would look almost asymmetrical. dominated by one brilliant light source, with a fainter companion trailing somewhere nearby. One particularly striking system, Kepler 47, turned out to host not just one circumbinary planet, but three, all orbiting the same pair of stars together. The first multi-planet system of its kind ever confirmed, suggesting that entire miniature solar systems, complete with multiple worlds, can form and survive around two suns at once, rather than just one. There's something quietly moving about the fact that this idea, once dismissed by some scientists as too unstable, too chaotic, too unlikely to ever actually exist in nature, turned out to be not just possible, but apparently common enough that we've now found multiple confirmed examples within a relatively small slice of our own galaxy. It's a gentle reminder that imagination, however fantastical it may seem at the time, often turns out to be less a fantasy and more a kind of distant, premature glimpse of something the universe was quietly building all along, light years away, long before we ever thought to imagine it ourselves. In the years since Kepler's primary mission ended, the search for circumbinary worlds has continued through newer instruments, including TESS, each new candidate adding another small thread to a growing tapestry of two sun systems scattered quietly across our corner of the galaxy. We have no way of knowing, yet, just how common these worlds truly are across the Milky Way as a whole, whether they represent a rare cosmic accident, or simply one more ordinary variation on the endless theme of planet formation, waiting patiently to be noticed in greater numbers as our instruments continue to improve. And speaking of things the universe builds quietly, far from any watching eye, our next stop takes us somewhere even stranger than a planet with two suns. It takes us to a planet with no sun at all. Every planet we have visited so far tonight, however strange, however extreme, has shared one quiet thing in common. Each one orbits a star. Each one belongs, in some sense, to a family, bound by gravity to a parent sun that provides light, warmth, and a fixed point around which to travel through the dark. But not every planet in the universe has a family. Scattered through interstellar space, the vast, mostly empty regions between star systems, astronomers have detected a category of object that defies almost every traditional definition of what a planet is supposed to be. They are called rogue planets, or sometimes free-floating planets. Worlds with no parent star at all, no sun to orbit, no fixed point of light to anchor them in place. Instead, these planets drift, slowly and silently, through the vast emptiness between star systems, illuminated by nothing but the faint, distant light of stars they will never come close enough to actually orbit. How does a planet end up alone like this? The leading theory suggests these worlds likely formed the same way ordinary planets do, coalescing from the same disk of gas and dust surrounding a young, forming star. But at some point in their early history, through a close, chaotic gravitational interaction with another planet, or perhaps a passing star, they were violently flung out of their home system entirely, ejected into the vast emptiness between the stars at tremendous speed, never to return. Once ejected, a rogue planet simply continues drifting, alone, forever, carried only by the momentum of that initial violent ejection, with no star's gravity to ever pull it back into a stable, familiar orbit again. Try, for a moment, to imagine the experience of such a world. Though it likely has no atmosphere capable of supporting any kind of weather we would recognize, and certainly no observer to ever witness it directly. A planet drifting through absolute darkness, lit only by the impossibly faint, distant glow of thousands of stars scattered across the sky, none of them close enough to provide any actual warmth, any actual daylight, any actual sense of orbit or season or time. A permanent, silent midnight, stretching not for a single night, but for the planet's entire existence, potentially for billions upon billions of years. Some of these planets may have formed in this isolated state from the very beginning, condensing directly out of vast interstellar clouds of gas and dust without ever forming around a star at all, born, quite literally, into permanent darkness, never having known any other kind of existence. A few of these wandering worlds have even been given names. One, catalogued as CFB Seer 2149-0403, was identified drifting roughly 100 light-years away, with a mass several times that of Jupiter and no detectable parent star anywhere nearby. Another, SO J318-522, discovered through a wide-field sky survey based in Hawaii, stood out for its unusually deep reddish color, likely the glow of a turbulent, cloud-streaked atmosphere, observed not in daylight reflected from any sun, but purely in its own residual heat, drifting through the dark roughly 80 light-years from Earth. Astronomers have detected dozens of likely rogue planet candidates over the past 2 decades, primarily through a technique called gravitational microlensing, watching for the faint, temporary brightening of a distant background star's light as an unseen object, such as a rogue planet, passes directly between that star and Earth, its gravity briefly bending and magnifying the starlight behind it. Like a fleeting, invisible lens drifting silently through space. Some estimates, based on the frequency of these microlensing events, suggest there could be billions of rogue planets drifting through our galaxy alone, potentially even outnumbering the stars themselves. Billions of worlds, each one as large, in some cases, as a true planet. Each one potentially complex in its internal geology and composition, drifting alone, forever, through endless, silent darkness, completely unconnected to any star, any system, any family of worlds. It is, in a strange way, one of the loneliest images the universe has to offer. And yet, loneliness on this scale may simply be a matter of perspective rather than fact. From the vantage point of a rogue planet, if such a vantage point could ever exist, the sky would not feel empty at all. It would still be filled with thousands of faint, distant stars, the same patient, ancient light that has always filled the night sky everywhere in the galaxy. The planet would simply lack the one thing that turns starlight into warmth, into seasons, into seas, a sun close enough to call its own. And yet, and this is worth sitting with quietly for a moment, even total isolation, even billions of years drifting through permanent darkness, does not necessarily mean total emptiness. Some scientists have proposed that certain rogue planets, particularly larger ones with thick atmospheres, may retain enough internal heat, generated by their own gravity and radioactive decay deep within their cores, to maintain liquid water far beneath their frozen surfaces, sealed away from the starless sky above by miles of solid ice. A hidden ocean, glowing faintly with internal warmth, sealed beneath an ice shell, drifting silently through the absolute darkness between stars, completely disconnected from any sun, and yet, perhaps, not entirely lifeless. We have no way of confirming this, we may never have the technology to send a spacecraft far enough, fast enough, to actually visit one of these wandering worlds and check. A future mission, NASA's Nancy Grace Roman Space Telescope, is expected to dramatically expand this search once it begins its survey, using the same microlensing technique on a much larger scale. Scanning vast stretches of our galaxy's crowded center, in search of exactly these kinds of faint, fleeting gravitational signals. Astronomers expect it to potentially reveal thousands more rogue planets than have ever been catalogued before, an entire hidden population of wandering worlds finally beginning to come into view. It's worth pausing on just how different this particular search is from almost everything else explored tonight. Every other world we've visited was found by patiently watching a star, waiting for a planet to interact with it in some measurable way. Rogue planets, by definition, have no star to interact with at all, which means finding them depends entirely on a fortunate, fleeting alignment with some unrelated star far beyond them, glimpsed for only a matter of days or weeks before the moment passes and the alignment is lost forever. Every confirmed rogue planet, in a very real sense, is a small cosmic coincidence, caught at exactly the right moment by someone patient enough to be watching. But the simple fact that the question can be asked, that a planet, utterly alone in the dark, might still, somehow, somewhere deep beneath its frozen crust, hold warmth, feels like an appropriate note to carry with us as we move toward the final, and most important, destination of tonight's journey. Because everything we have seen so far, the diamond depths, the iron rains, the pink glow of youth, the twin suns, the silent wanderers in the dark, has been building, slowly and deliberately, toward a single answer. The planet that astronomers quietly, almost reverently, call the most beautiful ever found. It's time, finally, to see it. 64 light-years from Earth, in the constellation Vulpecula, the Little Fox, there orbits a gas giant that, for a brief, quiet moment in the history of astronomy, became one of the single most studied objects beyond our own solar system. Its name is HD 189733b. This particular planet was first discovered in 2005, found through the transit method we explored earlier tonight, as it passed in front of its parent star roughly once every 2 days. What made it immediately valuable to astronomers wasn't just its existence, but its circumstances. Its parent star is unusually bright and unusually close, making this one of the most observable transiting exoplanets ever found at the time. In the years that followed, it became something like a favorite subject for telescopes around the world, and in orbit above it, studied, restudied, and studied again, each new generation of instrument adding another small piece to the picture. At first glance, the basic facts about this planet seem almost familiar, even comforting, compared to some of the extremes we've encountered tonight. It is a gas giant, slightly larger than Jupiter, orbiting its star, a star similar in many ways to our own sun, though somewhat smaller and cooler. At an extremely close distance, completing a full orbit, an entire year, in just over 2 days. Like several of the worlds we've already visited, HD 89733b is tidally locked, with one side permanently facing its star in blazing daylight, and the other locked in permanent night. Surface temperatures on the day side reach roughly 1700 degrees Fahrenheit, hot enough to make any thought of a comfortable visit entirely impossible. So far, this might sound like simply another violent, scorching gas giant, similar in many ways to others we've discussed tonight. But in 2013, astronomers using the Hubble Space Telescope achieved something that had never been done before for any planet beyond our own solar system. By carefully measuring the way the planet's light changed as it passed behind its star, comparing the combined light of star and planet together against the light of the star alone, researchers were able to determine, for the first time in human history, the actual visible color of an exoplanet. The method itself was almost deceptively simple in concept, even though it required extraordinary precision to actually carry out. As HD 1T9733b passed behind its star, an event called a secondary eclipse, its own light briefly vanished from the combined signal reaching Hubble's instruments, leaving only the star's light behind. By subtracting that star alone measurement from the earlier star plus planet measurement, taken just before the planet disappeared from view, astronomers could isolate the small, precious sliver of light belonging to the planet by itself, and, crucially, study exactly which wavelengths, which colors, made up that light. And the answer left even seasoned astronomers quietly amazed. HD 189733b is a deep, vivid, cobalt blue, not a pale, washed-out hint of blue, not a subtle tint requiring careful instruments to detect. A bold, rich, almost impossibly saturated blue, strikingly similar, in initial photographs and artistic renderings released by NASA and the European Space Agency, to the deep blue marble of Earth itself. Photographed so many times from orbit by our own astronauts. For a brief, breathless moment, before the deeper science was fully explained, the resemblance was almost eerie. A planet 64 light-years away, scorching hot, locked in tidal extremes, utterly inhospitable to any form of life as we understand it, and yet, from a distance, glowing with nearly the same beautiful blue color as our own gentle, living home. It is, by the careful consensus of the astronomers who first measured it, and by the public fascination that followed in the years after, widely regarded as the most strikingly, vividly beautiful planet ever directly measured beyond our solar system. The first true color photograph, in a sense, of an alien world. But, and here is where tonight's deepest, quietest mystery finally reveals itself. That beautiful blue color has absolutely nothing to do with water, nothing to do with oceans, nothing to do with the gentle, life-sustaining blue that colors our own planet's skies and seas. The blue of HD 1T9733b comes from something else entirely. Researchers believe the planet's atmosphere is filled with clouds composed not of water vapor, but of silicate particles, essentially tiny particles of glass, suspended high in the scorching atmosphere, scattering blue light back into space in a manner similar, in some ways, to how certain types of haze and dust can scatter blue light here on Earth. A blue planet, made not of ocean, but of glass. The announcement captured public imagination in a way few exoplanet discoveries had before. Space agencies released artistic renderings of the planet, careful, scientifically informed illustrations rather than photographs, since no camera could ever capture an actual image at this distance, showing a deep blue marble glowing softly against the black of space. Eerily similar to the most famous photographs ever taken of Earth itself from orbit. News outlets around the world ran the story under headlines, comparing it directly to our own home planet, and for a brief moment, the public found itself genuinely moved by a world none of them would ever see with their own eyes. In the years since that original measurement, some researchers have continued refining the picture, proposing that the exact shade and intensity of the blue may also be influenced by other factors in the atmosphere. Clear sky scattering effects similar to what makes Earth's own daytime sky blue, layered together with the silicate haze, rather than the silicate clouds working entirely alone. The precise recipe behind the color is still being gently debated, refined study by study, the way most genuinely interesting questions in science tend to be. And the story does not end there. Those same powerful supersonic winds that we've already encountered on other tidally locked worlds tonight, winds capable of sweeping iron vapor from dayside to nightside on planets like WASP 76b, exist here too, on HD 189733b, reaching estimated speeds of over 4,000 miles per hour, among the fastest planetary winds ever measured anywhere in the known universe. And those winds do not move gently through this planet's glassy silicate clouds. They tear through them violently, shredding the tiny glass particles into smaller and smaller fragments before sweeping them sideways, horizontally, across the planet's scorching, storm-torn sky. In other words, it doesn't just look like rain made of glass on this planet. It may, quite literally, rain shattered glass, not falling gently downward the way rain falls here on a quiet Earth evening, but driven nearly horizontal by supersonic winds, sweeping sideways across a sky lit by the dim, distant red light of its parent star, shredding anything caught within those storms with the force of glass shrapnel moving faster than the speed of sound. A planet that, from a distance of 64 light-years, glows with nearly the exact same beautiful, peaceful blue as our own home. And yet, up close, impossibly, unbearably close, in conditions no human being could ever survive. That same blue beauty is forged from scorching heat, shattered glass, and wind speeds beyond anything ever recorded on Earth. This, more than anything else discovered on tonight's long journey through the dark, captures the central quiet truth that astronomers have learned, again and again, studying these distant, breathtaking worlds. Beauty in the universe is rarely simple. It is rarely safe. It is, more often than not, the visible signature of something extraordinarily extreme, heat intense enough to vaporize rock, winds powerful enough to shatter glass, pressures deep enough to forge diamond, translated, finally, patiently, through hundreds of trillions of miles of empty space, into a single, gentle wavelength of color that the human eye finds beautiful, almost peaceful, almost like home. We called this planet beautiful before we fully understood it, and once we did understand it, once we learned about the glass, the shattering winds, the impossible heat, many people, strangely, found it even more beautiful still. Not despite the violence hidden within it, but because of it. Because it reminded us, gently, that something can be genuinely breathtaking and genuinely dangerous at exactly the same time. That those two qualities are not opposites at all, but are, very often, simply two different ways of describing the exact same thing, viewed from two very different distances. Perhaps that is the quiet lesson hidden inside the title we began with tonight. The most beautiful planet ever found is not beautiful because it is safe or gentle. or familiar. It is beautiful because, from 64 light-years away, across an unthinkable gulf of empty space and unbearable time, it managed to remind us, however briefly, however faintly, of home. And in a universe as vast, as cold, and as silent as the one we actually live in, perhaps that quiet, distant resemblance to something familiar is the most beautiful thing any planet could ever offer us. There is an old, gentle idea in astronomy, the notion that our own Earth, photographed from far enough away, becomes nothing more than a tiny, pale point of light suspended in a vast, dark emptiness, indistinguishable at that distance from countless other points of light scattered across the same photograph. HD 1T9733b offers a kind of mirror to that idea, seen from the opposite direction. From here, sitting safely on our own small, fragile, living world, we look outward across 64 years of traveling starlight, and we find, waiting in the dark, a planet that mimics our own most cherished color. Not because it shares our gentle nature, but simply because physics, applied patiently enough, in enough different corners of the galaxy, eventually produces echoes of itself, again and again, whether or not anyone is there to notice. We were there to notice. That, perhaps, is the quiet privilege hidden inside this entire journey. Not that the universe is beautiful, though it clearly is, but that we happen to exist at exactly the right moment, with exactly the right tools, pointed in exactly the right direction, to see even a small fraction of that beauty for ourselves. We have reached the heart of tonight's journey. But there is still one more place left to go. Not a planet this time, not a star, not a distant point of light. A quieter place, a place inside yourself, where all of these distant, strange, beautiful worlds can finally settle, gently, into something resembling peace. Let's stay here for a while, in this quiet space, before the journey ends. Tonight, you traveled farther than almost any human being in history has ever physically traveled, not in miles, but in imagination, guided gently by light that left its source decades, sometimes centuries, before it ever reached the patient lens of a telescope on Earth. You visited a world that may be built, layer upon layer, from diamond, a world slowly dissolving into the very star that gave it life. A world where falling rain is made of liquid iron, and another where it might be made of shattered glass. Oceans without shores. Darkness deeper than anything found on Earth. A planet glowing with the last pink embers of its own birth. A world beneath two suns. Wanderers drifting alone through permanent night, far from any star at all. And at the center of it all, one quiet, simple truth kept reappearing, world after world, like a familiar melody returning gently between verses. Beauty and danger, out there in the dark, are very rarely separate things. The same intense heat that destroys an atmosphere is often the same heat that produces a brilliant, glowing color. The same extreme pressure that would crush a human body in an instant is the very pressure required to forge diamond, or to bend water into forms it could never take on the gentle surface of Earth. The same violent winds capable of shredding glass into rain are simply an extreme, exaggerated version of the same physics responsible for a quiet breeze drifting through an open window on a calm evening at home. Nothing about this journey was designed to frighten you. If anything, It was designed to do almost the opposite, to remind you, gently, that the same laws of physics holding your own body together, the same gravity keeping your feet on the floor, the same starlight that will rise again tomorrow morning, are the very same forces quietly shaping every single one of these distant, impossible worlds. Consider, for a moment, how strange it is that any of this is even knowable at all. A human lifetime, measured against the age of the universe, is shorter than a single heartbeat measured against an entire human life. And yet, within that brief, flickering span, a handful of patient, curious minds, building telescopes, designing instruments sensitive enough to measure a wobble smaller than a heartbeat, waiting years for the right alignment of light, managed to reach far enough outward to learn the actual color of a planet 64 light-years away. That is not a small thing. That is one of the quietest, most remarkable achievements our species has ever managed, and it happened so gradually, paper by paper, telescope by telescope, that most of the world barely noticed it was even underway. You are not separate from any of this. You are made of the same elements forged inside ancient dying stars long before our sun ever existed. The same carbon that may form diamond mountains on a world 41 light-years away. The same iron that may fall as rain across a planet 640 light-years away is also, quietly, part of you. Part of your blood. Part of the small, steady rhythm of your own heartbeat, right now as you listen to this. It can be strange, even slightly dizzying, to hold both of these truths at once, that you are impossibly small, a single brief life on a single small planet, circling a single ordinary star among hundreds of billions of others in this one galaxy alone, and that you are also, somehow, exactly the right size, exactly the right kind of curious, exactly patient enough to look outward into all of that vastness and find it beautiful rather than simply overwhelming. Most of the universe will never be seen by anyone. Most of those 5,000 confirmed exoplanets and the billions more still waiting quietly to be discovered will likely never be visited, never be touched, never be fully understood, not by you, not by any human being who has yet lived, and perhaps not by any human being who ever will. The distances involved are simply too vast. The speed of light, fast as it seems in any ordinary earthly context, becomes almost unbearably slow when measured against the true size of the galaxy, let alone the universe beyond it. And yet here is the quiet, comforting truth tucked inside that vastness. It doesn't need to be visited to be real. It doesn't need to be touched to matter. The mere fact that a planet of shattered glass exists, somewhere 64 years of traveling starlight away from the chair you may be sitting in right now, changes nothing about your daily life, and yet changes something, quietly, about how large the word home can be allowed to feel. Every star you have ever looked up at, on every clear night of your entire life, very likely has at least one planet of its own, circling patiently in the dark, waiting for light sensitive enough and patient enough to finally reveal it. The night sky you grew up under was never simply a sky full of stars. It was always, quietly, a sky full of unseen worlds, diamonds, oceans, iron rain, twin suns, wandering planets without a single star to call home, hidden in plain sight above you, the entire time, long before anyone built a telescope capable of proving it. There is a particular kind of peace available in remembering that. Not the peace of having answers, because we don't have many, not really, not yet, but the peace of knowing the questions themselves are endless, patient and quietly waiting, exactly the way starlight itself is patient, traveling for years, for centuries, sometimes for millennia, simply to arrive, gently, in exactly the right place, at exactly the right time, to be noticed by someone willing to look up. Think back, for a moment, over everything this single night carried you through. A planet that might be diamond all the way down. A planet slowly disappearing into the fire of its own star. Rain made of iron, and somewhere else perhaps rain made of glass. An ocean with no edge, hiding water that behaves like nothing in your own experience. A planet so dark it barely exists to the eye, and another so young it still glows faintly pink with the memory of its own birth. Two suns rising together over a world that, until recently, only existed in stories. And worlds with no sun at all, drifting alone, carrying perhaps, deep beneath their ice, a small and stubborn warmth. Each of those worlds is real. Each one is out there right now, in this exact moment, continuing to exist, continuing to orbit, continuing to reign or glow or drift, completely unaware that, for a few quiet hours, a single small mind back on a pale blue world spent some time thinking about it. There is no grand purpose required for that to matter. It simply does, the way any honest act of attention quietly matters, whether or not anyone else ever notices it happened. You don't need to solve any of these mysteries tonight. You don't need to remember the names of the planets, or the precise temperatures, or the exact distances in light years. None of that was ever really the point. The point was simply this: to give your mind a few quiet hours away from the small, immediate concerns of your day, and to remind you, gently, that you live inside a universe vast enough, strange enough, and beautiful enough to hold an entire planet that may rain glass sideways at the speed of sound, and an ocean world without any shore at all, and a planet that glows pink with the memory of its own birth, and still somehow to find room within all of that vastness for something as small, as quiet, and as fleeting as a single human life. Your life, tonight, listening in the dark to a story about light that is older than you, traveling toward a planet that will likely outlast you, carrying a color that, for a brief, quiet moment, looked enough like home to remind an entire species here on this small, blue, impossibly fortunate world, that we are not as alone in the dark as we sometimes feel. Rest now, if you'd like. The universe isn't finished being beautiful, and it isn't going anywhere. It will still be there, quietly turning, patiently waiting, the next time you decide to look up. Good night.